Hello aviators, and welcome to your commercial pilot course. While the instrument course took you way inside the airplane with total concentration on the coordination of navigation signals and control inputs, the commercial pilot course takes you outside the aircraft with a strong emphasis on seat-of-the-pants reactive flying skills and much more of the big picture approach to your flying experience. Commercial pilots are professionals engaged in various flight activities for compensation or hire. And because of their professional status, they should exhibit a significantly higher level of knowledge than a private pilot. So, if you're ready to take it to the next level and have even more fun with your professional pilot career, let's get started. To get started, let's talk about the four forces of flight. The lift is provided by your dreams. The thrust, or what really powers the aircraft, is your money. Reality, unfortunately, brings you down. And drag, well, that's the fourth force, and we can see what that is. Come on, we're just having fun. Hey, listen, let's get down to the serious end of this, okay? Four forces act on an aircraft in flight: thrust, lift, drag, and weight. Thrust is the forward force produced by the aircraft's power plant. Drag is the rearward force caused by disruption of airflow due to the aircraft shape and other factors. This force acts opposite of thrust. Weight is the combined load of the aircraft: people, fuel, cargo, or baggage, and weight pulls the aircraft down due to gravity. Lift works opposite of weight, acting perpendicular to the aircraft's flight path. This is accomplished through the center of lift. Wings are airfoils attached to the fuselage and serve as the main producer of lift on the aircraft. Wings can be installed in a variety of ways. Wings attached at the bottom of the aircraft are called low wings. Wings mounted at the midpoint are called mid wings. And wings attached at the top portion of the aircraft are called high wings. A side note here, many high-wing aircraft have external braces or wing struts to support the stresses imposed on the wing, especially during landing. Now, wings are made up of several key components: spars, ribs, stringers, skin, and flaps. The spars provide the main support for the wing. Ribs provide the thickness and shape of the wing, and the stringers run perpendicular to those ribs. They are directly attached to the skin and transfer stress from the skin to the foundational structure of the wing. The skin is what actually forms the wing and provides the shape for the air to flow over and around. Flaps are lift devices. They increase lift and induce drag for a given angle of attack. These devices are typically mounted on the wing's trailing edge. Flaps also provide a blend between high-speed cruising and decreased landing speed depending on flap position. Now, there are four types of flaps: plain flaps, split flaps, slotted, and Fowler. The plain flap increases the airfoil's camber, and the plain flap increases the wing coefficient of lift and moves the center of pressure aft. This will produce a nose-down pitch moment as the flaps are extended. The split flap is hinged to the underside of the wing and produces a slightly higher coefficient of lift than a plain flap. More drag is produced because of an increase in turbulent airflow around the trailing edge of the airfoil. The slotted flap increases the coefficient of lift more than both plain and split flaps. Slotted flaps work by directing high-energy air traveling from the lower surface of the flap to the upper surface, delaying the airflow separation. This is made possible by a duct that forms when the flap is lowered. And Fowler flaps are a form of slotted flap. This style of flap changes the camber but also increases the wing area. Now, this is achieved by the flap sliding rearward on tracks. Like other styles of flaps, the first stages increase lift tremendously with little drag increase, while the final portion increases drag with little gain in lift.